I'm not logged in. It's a bit, oh, there you go. That was easy. All right, so RDS, this is a database, right? So like on the EC2 computer, all we really have is, let me draw this. All we have, as you can imagine, we have this EC2 computer, right? And this has a file, if not a code base, that has Flask running in it. So we have, from Flask, import Flask, right? And then we do that Flask app thing, right? And somewhere along the way, we do want to like import a database and connect the database, right? We want to do that line import. I can move this. I cannot. We want to do like import scicop G2, and then down below probably do this connection equals scicop G2, right? Dot connect. Now normally, and what do we specify? When we do the connection? Well, generally we specify just like the database name, whatever that is. Foursquare dev. And we specify, I don't know if there's anything, maybe like the user and the password, okay? Now, normally that database, so far when we've just been on our local computer, that database has sat on our same computer, all right? But with what you can imagine is that we may, shut down our Flask application, yet we still want our database running, right? So that I can query it or whatever, right? It's like an independent service, right? It offers something. Whether or not we have Flask running, we still may want to query this thing. So we don't need to, and we don't really want to tie it to our Flask application so strongly. The only thing that's really going to tie it, so first of all, what we'll do is we'll have a separate database, right, called RDS, that also is in like the AWS ecosystem, but runs effectively on a separate computer, okay? And the way that we'll connect to it is inside the Flask application. When we import scicop G2, we will not kind of imply that this database lives here. In other words, it won't look for localhost, but rather we'll give it the domain name, the IP address, or the domain name called the host, right, of the RDS, okay? This may sound complicated, but just remember, we've essentially done this before. When we say, okay, instead of just doing PSQL and connect to the Postgres running on my computer, we've said something like, let's connect to a database running somewhere else on the cloud, right? Our EC2 machine is going to do the same thing. It's not going to look directly on its computer, but rather just say, okay, actually, this database is over here. It's running on this other computer. All right. Questions about that, right? All right. So let's get started. The way that we can do this, we just click on RDS. So this is another service. You can also search for it, put in the search bar, just put RDS. RDS gives you, this is just the database service in general. I think it just stands for relational database service, I think. But you can see that we can choose different kinds of databases. What do we want? We want Postgres. I'll do the standard create. I think it's what I did the last time. Okay, so what version do I want? Free. Always free. The database name, right? This is how we'll see. You can call this whatever. Database 3 is fine. The username, this is important to pay attention to because when we log in, right, we're going to have to probably pass the username. And then the password. As you know, last time I did this, our site got hacked. So I'm going to change my password to something. Probably the name of my company. And then we will allocate, we don't need 200 gigs of storage. And I think all this stuff is free, but just in case, Amazon is sneaky, let's make it smaller. And this is interesting. You may be tempted, right? Tempted to connect to an EC2 resource. But I would say don't do that quite yet, because this is going to, if you do this, connect to an EC2 resource, then notice it does not give you public access. So basically, if you do connect to an EC2 resource, it will only allow, it will allow this thing. Basically, it will say, okay, I'm going to, have this firewall, and this firewall will allow access from this EC2 resource, this EC2 machine that I specify, but it will shut down, right? It won't make this more publicly accessible, which for right now I think we want, right? Because we're going to want to log in from our laptop. This is me drawing a laptop, and have this also kind of try this out to connect to our RDS. And if you do the connect to connect to EC2, it will only allow connections from the EC2, not from your laptop. All right. So instead, we will do don't connect to an EC2 resource. Notice, right? Here I do connect to an EC2 resource. See, it's not publicly accessible. Here I do don't connect, and now it is publicly accessible, right? Make sure this is checked to yes. All right. Next thing is the security group, right? This is our firewall. So I'm going to create a new security group. I'll just call it like RDS sample. And I would do like to look at this, and you can see, okay, additional configuration just has this port 5432. Password authentication, this means that we just have to put in this password that we set up here. And we don't need performance insights. This is like seeing how well your database does or something. We don't need it. Additional configuration. Yeah, you can give like yourself an initial database name. We won't. We can give backups. We don't need it. Enable encryption. I don't think we need that either. Like this stuff, it's not a big deal. You can skip this whole section if you want. You can leave the defaults, it's fine. All right, and now let's create a database. So just to review what we did so far, right? We set this to Postgres. We set the free tier, right? We gave itself a name. That's why we know what we're referring to. The Postgres, we have to, set the password. This is how we're going to log in. Micro, that sounds good. This is the smallest. We scaled this down. It says the minimum is 20. We made it 20. We did the don't connect to an EC2 resource. This way we can make it publicly accessible. These I left kind of the default. And then the security group, right, is our firewall. I created a new one, and we'll deal with that a little bit later. And now let's just do create database. All right, so this is the database I'm creating now. Is this database 3. The main thing that we're gonna look for, or like have to wait for, is the endpoint, right? Which is another name for the domain name, or like the URL that we'll ultimately want to connect to with. And then what I will want to do is, go here and essentially do PSQL host, or I think you could also do dash lowercase h or capital H, I forget which one. Let me just see. Yeah, lowercase h apparently. So I'll do the host, and then we'll say the endpoint, and then we'll say the user, capital U, I believe. And that was, I think, Postgres. If you forget the values, I'll show you on a different database. Once this is created, if you forget your password, for example, you can go here and click modify, right? Just click on the database, click modify, and then you can, reset your password, reset the username. One thing, look at this. One thing that's very easy to do, it automatically wipes out your password. So even if you're like, I want to change something else, you have to pay attention to this, right? Because it's asking for a new password effectively. All right, the second you click edit. Let's see. I'll just put in a password. And then everything else is fine. I'll do continue. I would like to work with this one, the new one. Any questions while we wait for this thing? All right, so this, I'm looking at the different kind of values here. It says publicly accessible. That's one thing I'm looking for. The other thing I'm always paying attention to, when like something goes wrong, the thing that is most likely to be off is the security group, okay? So let's click on the security group. All right. So here's my security group. What I care about most are the inbound rules. And we can see that it is allowing accessibility maybe on port 5432, but I also see something weird here. Search.
So does the database sits on the computer, the EC2, or it's on the hard drive?
Neither. It's on a separate. We have an EC2 machine is on one. It is on one computer, and the RDS, the database, is on a separate computer. We're going to connect them by specifying the IP address or the domain name of the database of RDS. All right, so the way that we'll do this is our Flask application will ultimately have this, okay, I'm going to have scikopchi do .connect to wherever the IP address or the domain name of this RDS instance. So it's going to know where to go to query, our data.
By that you mean another computer, you mean another EC2?
Yeah, it's probably an EC2. I don't really know what it is. It's some sort of computer that has Postgres installed on it, Yeah. Cool. All right, let's see how this is going. I'm going to go back here. Go back to the RDS. Oh, it says successfully created. Let's take a look. Okay, so now that it's created, you can see we were given an endpoint, meaning we were given a domain name, and now we can ideally try to connect. I like to try to connect to these things first by using the PSQL thing from my terminal. So let's try that. So we're going to do PSQL-H, and then the endpoint is this. So I'm going to copy and paste this. Now, if I just press return here, it's going to break because it's asking for the password for user Jeffrey Katz, which I guess is some like default on my personal laptop. But if you remember, on AWS, we didn't create a user called Jeffrey Katz. We created a user called Postgres. So I can type whatever I want here. It's not going to work because there's no username with this. So what I need to do is put cat-u. I need to specify the user as being Postgres. All right, now this looks better. And we're connected. Okay, so I just put in the password, and now we're in. Remember, we were given the option to create an initial database. We did not do that. So we only have like these ones. But we can, create a database. This is just Postgres. So we can call it like Foursquare development, if I can type, semicolon. And then we can connect to the database. Remember how to do that with the \C. Foursquare development. Now we're connected. And now we can do let's create a table. Create table venues. And we'll just do the ID is serial. And let's do like name is varchar like 250. I think that's okay. Normally I would not at all ever recommend writing it this way. I would recommend, in fact, let's do it. What I would recommend doing is, let's quit out of here. Let's see what I was working on. Let's create a file called createtable.sql, and then let's do code createtable.sql. Like modifying your database is pretty drastic action. You generally don't want to just code it in there, and you want to have a record of like what you did. So it's, if you just code it directly in your terminal, well, there's no git commit, right, associated with it. There's no history really of it. So instead, we'll have this in this .sql file, if we save it properly. And then we'll do PSQL. Let's just press the up arrow. -h, -u, and now what do we need to do? Run the file, right? With -f, create table.sql. So this will say, okay, go to this location as the user Postgres, run this file from your computer, and now it asks for the password, and it seems like it worked. All right, we can confirm it by logging in. Oh, you know what it did? It created the table probably on my Postgres database. Yep. It's okay. If we wanted it to create it on my Foursquare database, we would do -d Foursquare. What's it called? I think Foursquare development, right? Oh, I did not run. Hold on. Sorry about that. I connected, but I did not put in the -f, which is what I want to do. So now, at this location on this computer, right, this web address, as the user Postgres, on the Foursquare development database, run this file. That's what I'm saying. Type in your password. And now it seems like that worked. Let's connect to the database. And here we're in Foursquare development. We can display, we see that we have this. Let's get rid of the other one. So we'll connect to Postgres, and we'll just do display the tables. And then we'll do drop tables, table venues. All right, now things are pretty good. Let's just make sure. Yeah, so we have that one. Okay, so we have, so far, created our database, and we have connected to it from our computer, right, from my laptop. What we want to do is be able to use the library, like use scopg2 to connect to the database. So let's try that next. So I'm going to have a Google Colab, all right? And in order to have Python to connect to a database, what I need to do is, first we need to make sure we have this scopg2 binary, right? So let's install that. And then after that, we can do import scopg2. Then from there, we'll wait a second. Ultimately, we're going to want to call this connect function, right? Okay, so this is installed. We should be able to import scopg2. Now we need to specify the host. The host, you can see these parameters. Let's take a look. Database name, the name of the database. I think that we know what that is. User, password, host. Let's just copy these. So we need the host. The host should be this AWS thing, this endpoint. So let's put that here. I'm going to actually store it as a variable. Sorry, this thing. All right, so that's my host. We probably want the database, or we can call it DB name. Maybe that's a little better. Equals, and that's Foursquare development. And then we want the user, and that's Postgres. And then we want the password. All right, everyone close your eyes. All right, so now I'll do connection. And then this is not going to work. Okay, so why will this not work? The reason why is because Amazon tried to help us out, right? And let me show you how. So remember, I said if we have issues, the problem is probably with our security group. This is what I think. All right, so here's my database 3, and then here's my security group rules. Here's the inbound rule, all right? let's click on my security group, right? So in order to edit it, you have to. I'm going to go back to my database. You see this link here? You have to click on this link, and now we're just going to be at a page just about my security groups. And then here's my inbound rules. And now I'm going to need to edit my inbound rules. Okay, so I'll show you the problem. So here's the problem right here. Okay, what this is saying is, right, we have this firewall that's like blocking our RDS instance, my database. But it's saying, this rule is saying, hey, we will allow access on port 5432, but only to my laptop. Amazon did that for me automatically, right? But now I'm on Colab, and Colab is like somewhere on Google's computer, and this thing doesn't have access. So what I need to do is basically is delete this, and then just say, okay, anyone, because I don't know their, I mean, I could find their IP address, I guess, but we'll just say anyone, and then save it. So right, all the zeros mean anyone can do it, and then we'll save this, and now I'll just look at my inbound rule, and you can see that if you scroll over, you can see that now source has changed. Now let's go back, now that we've kind of opened up our firewall, and I'll just do restart runtime. That's fine. So restart the runtime, import sitecop g2. That's working. Connection. Now, see how quickly that... So, okay, so far, I'm not sure if I'm sharing. I'm not. Cool. All right, so here's kind of the first thing we dealt with, which was, like this Flask application, right? And we have, we have our Flask application where we have like this import Flask, or from, more likely it's like from Flask, import Flask, and then we create the app, right? And then this thing, what's important about this thing, our Flask application, is that, well, it sends back right, and then it does something like def venues, and then we have this connection, and then or maybe even a cursor, I forget what it was, get db, how it returns to us the connection, and then we do connect, and I'll make this bigger, this is getting miserable. And then we have connection dot cursor, something like that, and then we have cursor dot execute, right, select all from venues, something like that. We could also call like the venue.all or that find all method, but ultimately what we're doing is we have some sort of Flask application that me as like a user, can I just show like a laptop? Yeah, me as like a user can go and make a request, right, to my Flask application, and I can get back, right, a list of dictionaries, which is really what I want because we like them. And, like venue 1, right, and then venue 2. And right, so that's the job of obviously like our Flask application. Our database, this stores obviously our data. And one thing to note is that you may want to scale the database for different reasons. Like, just because you want to scale the database doesn't mean you want to scale the Flask application. What do I mean when I say scale it? I mean throw more like hardware at it effectively. So for example, if our like web application becomes pretty popular, then we may want to like add CPU resources to it so that it can get requests, get someone, get many computers making requests to it, and then send back responses. We may also want to duplicate it. Like you can see, we don't really get into this, but you can literally like copy and paste, have multiple EC2 instances, each of which have the same Flask code on it. And then sometimes we would make a request, the user would make a request to this one. And then sometimes, a different user would make a request to a different Flask application, a different computer. All right. There would be, it could, I don't really want to get into like how this operates, but the point is like you can scale, you can add more computers that host your your web application. And when would you do that? If you get more users, effectively. All right. This way, you're not like clogging up or taxing one computer to the point that it just fries. Now, a separate problem is like, do we want to scale our database? Right? Like, who's accessing the database? Well, one is our users, right? Like these users, but others may be like, maybe like our developers need to access the database, or maybe like the data analysts directly access the database. Maybe we just like, there are companies that just give you access to a database, and you maybe, give developers access to a database. Like I can pay for access to a database and there's no Flask application involved. I just know SQL and so can call SQL. So the point is like, we may want to scale the database, right? Like meaning have this thing be more responsive, even if we don't get any more users to our website. Because of that, because like the amount of these decisions are separate, right? Because like I may want to scale the Flask API depending on if I have more people visiting this, and I may want to have scale the database because I have more people that know SQL just directly accessing it. I don't want to put the consequences that I don't want to put these things on the same computer, which right? So this is just me explaining why this is valuable. It means that we get to throw more resources at these two different components, the Flask app and the database, depending on, right, they don't have to scale up and scale down together. We can scale them separately. All right. So this is called like, you'll hear these things referred to, like the Flask app and the database. You'll hear these referred to as services. Okay. These are like two different services. And then you'll hear this kind of idea. Sometimes you'll hear this as like service-oriented architecture. I hate that term. It's probably something a lot of people hate now. But the idea is that if we separate these two things, then we can treat them effectively as separate entities, even though we know there's just this one line of code, our connection, that is like connecting the two. All right. Okay. So that's one thing I wanted to talk about. The other thing is, all right, so we like, how does Fivetran and like Snowflake fit into this? Well, like we said, every time a user kind of makes a request to venues, well, then that has to eventually call our database, right? And we want the response to the user to be like pretty fast, right? Because, if we're Twitter, we have lots of users, obviously. Okay, so we don't want to then like have our database analysts and like the internal company people making requests to the same database, right? Like they can make these like long running requests, like tell me something about all the users, right? Across like millions of users. And that takes a long time to query. And now this database is overtaxed while we need it to be up and running and ready for our end users, right? So what do? Well, we create a separate database, right? And that's Snowflake. And we need to copy the data into Snowflake, right? In this way, we can have the data analysts or data scientists or whoever, just data analysts, data scientists, it could be dashboards, right? They're going to be using Snowflake. One nice thing about Snowflake is like we only pay for it when we're actually performing a query. This thing, RDS, we need this thing to be up and running, right? It is humming. Okay, always. Why? Because we have users from anywhere and, different time zones and, people that can't sleep. And they need to be able to make requests to our website and get back a response quickly. All right. So we don't really have that same issue. Like people have to come into the office, they work 9 to 6. And like, we don't really need this thing to be running all the time. It's also, people we pay. So it's okay if they wait. It's our money. So this has just different needs. In the middle, we need to actually take the data from here and move it over here, right? That's what Fivetran is about, right? You may remember this, that what can we do? Well, we can put in our Postgres things like the domain name, right? The password, the username and the password, and basically give and password, and then do the same thing for Snowflake, right? And we give Fivetran access to our RDS. We give Fivetran access to Snowflake, and we can set rules that basically say, hey, every day or every week or every whatever, go to RDS, take the data, copy it into Snowflake. All right? Then we can have our data analysts, data scientists, whoever, access that data. All right? So this is kind of what we've learned so far, right? As we build Flask that then sits on RDS, right? Postgres in Amazon. They're on two different computers because we may want to scale them separately. And this is also just the way it's built. And obviously we know that our Flask application has to access to our database, which lives somewhere else. And then ultimately we want to allow internal people to query the database, but to query our data, I should say. So a good practice to do is not to have this be shared with the users, because now our users can get frustrated, but rather move the data over to Snowflake or Redshift, which is a competing. This is Amazon's version, or I forget what's called. What's the Azure? There's BigQuery for Google, and then it's something for Azure. All right. Micah, what is it? If he's here, or whoever knows can just tell me.
Is it Databricks?
Yeah, I think not Databricks. It's data something else. Data. Serge, I think you told me. But what's the thing that they asked you about? I don't remember. It doesn't matter.
Azure.
Yeah, but it was something else. Data plan or something like that. Data plan.
Data Factory.
Data factory.
PDF.
Thanks, Ina. Data factory.
Oh, there, Frank.
Okay, cool. Yeah. This is a competitor. All right, so the concept's the same. All right, we move the data over, then we query it here. We leave our users alone. Okay. And as we know, right, we have all those other reasons for moving it over to this too, right? This is column-based storage, right? Meaning that it's designed to handle, I guess this is a good time to review this, right? Other things, right? This hardware, the way that Snowflake is designed and Redshift is designed and BigQuery is designed is for answering questions about a single column, right? So we can say, give me all the users' birthdays to find the average birthday, right? Give me that one column. The way that this is designed is give me information about a row. Tell me everything about this one user. The other thing is the design of the tables is often different. Right here we have that OLTP structure. Here we have that OLAP structure. Right? This is designed for data analysts and whoever to answer questions. This is designed for like single source of truth, right? And fast inserts and updates. So we have a lot of tables that are each smaller. Here there are fewer tables that are bigger. All right, hopefully this helps like fill in the picture, right? The overall story as to what we're doing. Questions about this or anything else? Yes, Serge.
So, in a situation where a company they're moving their database on the cloud, can we use Fivetran to move this data?
Yeah, I mean, generally, like, as long as they have, like, Fivetran has the connection and the destination, you can do that. I think it's worth it. Right? Why do people maybe not want to use it? It costs money. But generally, an engineer's time is way more costly. If you think about it, like an engineer, like including overhead, is going to be like $100 an hour, like minimum. Right. Plus, and the project management, everything that goes along with it, right? All the people that are involved in allocating a story and like things that can go wrong and maintenance, right? So generally, it's a good move just to pay the money, right? Unless it's super expensive. But if you have a tool that's out of the box that costs $100 a month or a few $100 a month, it's generally worth it for most companies. Generally, companies will choose to pay for the hardware or pay for the software as opposed to pay for an engineer's time if they're to rebuild, right? Because otherwise, and we will show how to do this, how to load this data from one to the other by hand, right? And that's what we will get into, how to do that. But one thing you'll have to do is recreate all those tables, or redesign them and things like that. It just takes time. Yeah, other questions? No? Okay. All right, well, hopefully this was fun. I'll put you all back. I'll let you continue working on the lab.